Namaskar. Today we are going to discuss about the GABA A receptor. As you know, GABA is an inhibitory amino acid, gamma aminobutyric acid. It has two types of receptors. It acts on two types of receptor. One is GABA A receptor and other is the GABA B receptor. GABA A receptor is an ion channel linked receptor linked to chloride channel, and GABA B receptor is a G protein coupled receptor. So GABA A receptor, this is the central pore through which the chloride ion enters into the cell. So you can see this is extracellular, this is intracellular, and this is the transmembrane receptor, and it has 5 subunits. 5 subunits are there in this, and you can see 5 subunits: 1, 2, 3, 4, and 5. These 5 subunits can be alpha, beta, gamma, delta, epsilon, pi, and theta. So there are 6 types of alpha, 3 types of beta, 3 types of gamma, and then each one type of delta, epsilon, pi, and theta. So you can see here in this figure, so this is like this, these 5 subunits are there, and in the center there is the chloride channel. So this chloride channel is here, whose influx occurs from outside to inside. So here you can see 2 alpha 1 subunits are there, 2 beta 2 subunits are there, and 1 gamma 2 subunit is there, total consisting of 5 subunits, and the central chloride channel is there through which chloride influx occurs. Now this GABA is synthesized from glutamine in the exoplasm, and glutamine is converted to glutamate. Glutamate is then converted to gamma aminobutyric acid, and this GABA is then released into the synapse. Then it acts on the postsynaptic GABA A receptor, which is linked to chloride channel to cause chloride influx, and there will be hyperpolarization of the neuron. This GABA is also taken by the astrocytes, in which again the recycling of glutamine occurs. GABA is converted to glutamate, then glutamate is converted to the amino acid glutamine, which enters into the neuron. So the neuroglia, astrocyte and neuron both help in recycling of glutamine and GABA. So glutamine to GABA occurs in neuron, GABA to glutamine occurs in the neuroglia astrocytes. So you can see the different sites. This is the GABA site between the alpha 1 and beta 2, and you can see 2 GABA sites are there to which GABA binds. So you can say this is the receptor site to which GABA binds. Similarly, there is another site called receptor modulatory site. We can call it as receptor modulatory site, and this receptor modulatory site is nothing but your BZ receptor site. BZ receptor site, and BZ receptor is of 2 types: BZ, BZ1, BZ2. BZ1 is also known as omega 1, BZ2 is also known as omega 2. So this is the site between the alpha 1 and gamma 2 subunit. This is the BZD or benzodiazepine site. And you can see here these are the sites to which GABA binds, and this is the site to which benzodiazepines bind. There are other sites like channel modulatory site to which barbiturates, neurosteroids, alcohol, all these bind. So this is called channel modulatory site. And there is other site also, yes, for alcohol it is shown here. So other sites, we call these sites as the channel modulator sites. And there is another site also called as the channel blocking site, channel blocker site, to which channel blockers like picrotoxin acts, which is a channel blocker, and picrotoxin we use experimentally as a convulsant to induce convulsions in rodents. So one is the receptor site to which GABA binds, receptor site, and another is the receptor modulator site to which benzodiazepines bind, receptor modulator site. And similarly we have channel modulatory sites, and we have channel blocker site. So different, you can see here in this figure we have 2 alpha 1, 2 beta 2 and 1 gamma 2. And here the GABA binds to this black color one. This is GABA binding site. Then the red color, this is the benzodiazepine binding site. Then the green color, this is the neuroactive neurosteroids binding site. Then this is the barbiturate binding site, and this is the etomidate binding site. So different sites to which different drugs bind. So you can see here 2 alpha subunits are there, 1 beta subunit is there, and the other 2 subunits, one subunit can be either from gamma or delta or epsilon or pi, and other one can be either from beta or theta. So 5 subunits together form this ion channel, and these are the different sites as we have discussed for all the drugs. All these drugs act, and propofol, the general anesthetic, this also binds to the site on this GABA A receptor. So if we summarize them, let us summarize. Let us make it a simple diagram. So say this is the GABA A receptor, a transmembrane receptor. This is extracellular outside, and this is inside, and this receptor is linked to the chloride channel. And when this chloride channel opens, it causes hyperpolarization. There is a receptor site to which agonist is GABA acts as the agonist and opens the chloride channel. Then the other agonist is mosimiol, and here antagonist is there. Antagonist is bicuculin. Similarly, there is another site we call it as the receptor modulatory site, and this receptor modulatory site we can call it also as the BZ receptor or omega receptor, and this receptor is of two types, BZ1 and BZ2. BZ1 and BZ2. BZ1 is also known as omega 1, BZ2 is also known as omega 2. So benzodiazepines act as agonists. Benzodiazepines like diazepam, lorazepam, flurazepam, alprazolam, midazolam. So all these benzodiazepines act as agonist on this site, and the antagonist here is flumazenil. Flumazenil is the antagonist, and it acts as antagonist on both omega 1 and omega 2. So this is non-selective. Benzodiazepines are non-selective and flumazenil is also non-selective. So both these are non-selective, means they act on both BZ1 and BZ2. However, there is another group of drug which is BZ1 selective agonist, that is zolpidem, imidazopyridines like zolpidem, alpidem, and the advantage with this zolpidem, alpidem is they are anxiolytic, and they show sedative hypnotic action, but they lack the anticonvulsant and muscle relaxant activity of benzodiazepines. Benzodiazepines also show muscle relaxant activity, anticonvulsant activity, which these drugs lack. And the other disadvantages with benzodiazepines like tolerance, dependence, withdrawal syndrome, all these are also absent with these drugs because they are BZ1 selective. So BZ1 selective drugs, they have less tolerance, less dependence, and so they lack the withdrawal symptoms. So this is the advantage of these drugs. They are only anxiolytic and sedative hypnotic drug, and they lack the muscle relaxant and anticonvulsant activity of benzodiazepines. Then we have another site called channel modulatory site. So to the channel modulatory site, many drugs bind. Channel modulatory site. To this site, drugs like barbiturates, alcohol, or for example ethanol, neuroactive steroids. So all these act on different sites. Combined we call them as channel modulator sites. Then there is another site called channel blocking site, to which drugs like picrotoxin binds. They are the channel blocker. So in this way we can summarize the different drugs acting on the GABA A receptor. And there is a difference between the receptor modulatory site and the channel modulatory site. Benzodiazepines, when they act on the receptor modulatory site, they increase the frequency of opening of chloride channel. So by increasing the frequency of opening of chloride channel, they produce hyperpolarization. And because of this hyperpolarization, they show all these actions: sedative hypnotic action, anxiolytic action, muscle relaxant action, anticonvulsant action. Okay. And barbiturates, they also cause hyperpolarization, but in a different way. They increase the duration of opening of chloride channel. Duration of opening of chloride channel. So both benzodiazepines and barbiturates open the chloride channel, produce hyperpolarization, but the difference is benzodiazepines increase the frequency of opening of chloride channel and barbiturates increase the duration of opening of chloride channel. So this is all about the GABA A receptor. Thank you.